Hi, good afternoon. Um, so today I'm going to ask the question, how do we automate condition-based asset maintenance, right? These are complex workflows, and much of the focus of my talk is going to be the use of the new turn in Gen AI, agentic frameworks, to enable this. So let me start with, some intuitive definitions, right? Condition-based, maintenance. So the basic idea is that rather than doing, say, calendar-based or time-based maintenance, we actually evaluate and estimate the health of an asset, right? And based on the condition of an asset, we decide whether to initiate a work order or not, right? Now, of course, if you look at the PF curve, right, it gives us a little more intuition. Often, calendar events might end up doing maintenance when the assets are, running smoothly, right? So unnecessary work orders, or maybe do it too late, right? Lead to, unplanned downtime, right? However, if you sort of consider sort of a condition-based approach, and I put a workflow in here to sort of highlight what are the steps involved. For a given asset, you want to identify what are the failure modes, right? And then collect data with which you can check for specific failure modes, right, or condition, or the health of an asset, and then based on that, act in terms of what is the work order or the job plan that you want to initiate. Now, of course, Maximo has several components that enable several steps within this workflow, right? So now comes the question of, okay, if we want to do these kind of condition-based workflows as part of our asset management strategies, right, how do I sort of help to automate these workflows, right? So you might ask the question, why automate, right? First of all, condition-based management has some complex tasks that are involved, right? First is, for example, understanding the FMEAs or the failure modes of an asset, which requires fairly deep domain expertise, right? And then on top of it, you need some data science to be done to understand how do I use sensor data to evaluate or estimate for specific conditions that are specified by the FMEA. And of course, doing CBM leads to a lot of value, right? Productivity and efficiency gains. So today, actually, this morning, and Mike also sort of highlighted some of these examples in Mass 9, right? We've already started to bring large language models as part of Gen AI to enable things like FMEA content builder, right, on top of reliability strategies, or work order intelligence, right? It automates problem code classification, right? So these are really good examples where some automation is already being embedded into these kind of workflows, right? However, right, the next step is to really consider to what extent can I automate the workflow, right, using agentic frameworks, right? So the idea really here is, you want to go beyond LLMs, right? In the sense that you want to teach LLMs the ability to use APIs, right? To use different functions within the mass ecosystem, plus the surrounding APIs from an IoT perspective as well, right? To be able to actually access data, access nameplate information for assets, access sensor data, access work orders, automatically to sort of do reasoning to figure out how to do the entire CBM workflow end to end, right? So I'm going to elaborate on this a little bit and show you a couple of examples, right? But before that, let me sort of talk a little bit by what do we mean by agents and agentic workflow, right? So we are all now familiar with LLMs. Most of us love it or hate it. Use ChatGPT all the time, right? And they've been trained on large sets of data. They know how to do some Q&A. But the next step with LLMs is really this idea that maybe LLMs can be taught to use tools, right? I mean, it's a nice analogy to evolution, right? When mammals started to learn tools, the use of tools, right? Maybe LLMs are heading in the same direction, right? And start with simple tools like using a calculator or doing a web search to get information, to really complex tool usage like using enterprise-level application APIs, right? And then we could actually train these LLMs with domain-specific data so that they are better at using tools in particular domains, right? We are specializing them. And finally comes the idea of an agent, right? So the notion of an agent in this context is an agent is an entity that's able to plan in response to a query or a job, a set of tasks that it needs to do, reason about how to do these tasks, and then based on that, take some actions, right? By calling an API to do something, right? Look at the outcomes and actually reflect on it and self-correct, right? And that is the notion of an agent that we want to introduce, right? And this is, in fact, sort of the exciting new direction of Gen AI today, right? Now, let us think about what does it mean to bring an agentic workflow, right, in the context of asset lifecycle management and CBM, right? So at the center of this picture gives you sort of a very classic framework of the way we think about agentic, think of agentic flows, right? There's a think, act, generate, and observe kind of a loop, right? So essentially, the agent has the capability, given a query, for example, a query to trigger, say, service requests, come up with a plan how to do that, right? And then take appropriate actions to gather information about what is the next step. Based on the outcomes, actually observe the outcomes and then do some self-reflection to see whether the outcomes are meaningful. If not, correct for it and redo it. So that is the general framework, right? But now if you want to bring it into CBM, right, think of it as a maintenance planning engineering agent. That agent needs to understand how to use data and tools in this domain, right? Data which is about assets, right? Equipment asset hierarchies. Sensor data, right? A lot of it is time series. Work orders, historical work order data, and then different modes, right? Failure modes that are associated with an asset. And then on the other side, the ability to actually use tools relevant for CBM, like use an FMEA builder to understand, okay, these are the failure modes, right? Go to the IoT tool to pull relevant data based on what it has observed from failure modes, right? Use models, say, for anomaly detection. Even generate code in an attempt to understand the condition of an asset, right? So really, these are the kind of tools that you want to enable the agent and the agentic workflow to be able to use, right, to do an end-to-end workflow. Okay, so we've started to do this in the context of a class of assets like chillers and air handling units, working with our global real estate within IBM, right? This is the Poughkeepsie data center. And what I want to show you is a demo of what we've started to already pilot in that setting to give you a sense of the kind of automation that it brings and the way these Gen AI models can really enable the next level of automation, right? So I'll show you two scenarios, right? Scenario one is really, in some sense, the ability for this agentic workflow to address questions like the one that is posed here, right? A particular chiller is overheating, that's the alarm or the alert that we get, say, from Maximo. So what we want to do is, do we need to generate a service request? And if needed, please go ahead and do it. So this requires root cause analysis, right, in response to this. So what I'll show you is how does the agent actually go plan out multiple steps in order to figure out, to validate if there's a problem and which failure mode it sort of corresponds to. And then based on that, go ahead and sort of do the analysis to sort of validate whether something is wrong, and then generate a work order. And then time permitting, I'll show you another sort of scenario, which is essentially a scenario which is a sort of a very smart agentic assistant where an SME might look at a particular alert and say, oh, I want to actually test for this kind of a rule, right? So here, for example, I want to check for a rule that says if the power is over 1,000 kilowatts and the condenser water flow is very high, then you want to raise an alert. So go check for this condition and come back to me to show whether it's valid or not, right? So I'll show you how this whole thing is automated using an agentic workflow. So this is like a 2-minute video demo that will sort of highlight this.
In this scenario, MPE agent is tasked to generate service request recommendation if chiller 11's compressor is overheating. Before I start the demo, I'd like to show how we configure an MPE agent. We have included 9 domain-specific tools, along with the description in the system prompt of MPE agents. Additionally, we have provided 4 examples in React style for in-context learning. Given this setting, now let me demonstrate the working process of the agent. In the first step, the agent generated a thought to check whether overheating is a relevant failure mode for chiller asset. In a response of these thoughts, the agent selected a tool called Get Failure Mode Information with the correct parameter. As you can see that overheating is listed one of the failure mode for chiller assets. Next, the agent generated another thought to check whether there's any sensor variable that can be used to monitor the overheating condition. Again, agents used another tool to obtain a list of sensor variables associated with chiller 11, and we can see that a few sensor variables associated with temperature. The third step is interesting as agent generated a thought to obtain the sensor data for analysis, but ended up invoking the wrong tool. Here, the agent is invoking failure mode tool to obtain sensor data. As a result, what the agent do in the next step is very interesting, as we can clearly see that the agent repeated the previous thought. However, this time it selected a right tool to obtain the sensor data. Since the sensor data is downloaded, in the subsequent steps, the agent focused on anomaly detection. It realized that it needs a fine-tuned TTM model for chiller 11. Finally, you can see that the anomaly is detected in a temperature signal using the tuned model. Since an anomaly is detected, the agent now proceeds to generate a Maximo service request description using LLM and validate it using LLM as a judge tool and Maximo work order data. In step 11, finally, the agent concluded. In summary, this demo highlighted three important aspects of agentic workflow. First, the dynamic orchestration of the tools along with recovery from the failure. Second, use of TTM for anomaly detection along with the fine-tuning model. Third, use of LLM for a service request creation.
Okay, so hopefully that gave you a sense of sort of the way the agent was able to actually plan out multiple steps, 11 steps in this particular context, right? Where it essentially each step was, some sort of the next step that the agent reasoned is the right thing to do, right? And I just want to highlight a couple of things in here, right? So, for example, the agent figured out that in order for me to check this, I should go get the right FMEA and check if the chiller temperature is actually a failure mode, right? Once I validate that, the agent then figures out, in order for me to test for this, test for an anomaly, I need to go find the right sensors. Do I have the right data, right? So evaluate sort of the availability of the data. Then go use a model for asset health to test for that condition, right? And it turns out it doesn't find a model. So it actually takes an off-the-shelf model, fine-tunes it with the data available to be able to then do the inference, right? And then establishes that indeed there is an anomaly that satisfies a failure mode, and then goes ahead to say, okay, let me do a service request, sort of something that I initiate, right? And the other thing that's interesting to highlight in this context, right? So another thread that is really big in terms of foundation models and Gen AI is something that Mike also highlighted, right? New modalities like time series where pre-trained models on publicly available data have become available, right? So in fact, IBM Research has built such a model and made it available in the public domain. It's generating a lot of interest, right? Because off the shelf, you can use it for a particular setting, or sometimes with very little data, you can customize it pretty automatically, right? So we have over 700,000 downloads of this model, right? And that is exactly the model this agent also downloaded and used, right? Because it was one of the tools that we said you can go ahead and use. Okay, so the other example that I wanted to quickly highlight is an agent that's able to go write a bit of code to test for a particular rule logic, and then validate that code and come back to establish the condition of an asset, right?
Hello, everyone. The demo that's going to be presented highlights a capability that allows MPs to specify rules to monitor assets and turns them into executable code to be tested against available sensors data. The agent is configured via a system prompt to plan and act using a set of tools and to adapt given their outputs, or lack of it in case. Here we have an example of a rule that is normally used to monitor the health of a chiller. We identify anomalous behavior if both the power input and the water flow surpass some threshold and the behavior continues for more than 2 hours. The MPE agent generates a plan to convert this rule to code and run it against the available data. So the first thought in the plan is to retrieve the list of available sensors for this asset and evaluate whether they cover the conditions in the rule. A dedicated tool to prove this turn is called by the agent. The second thought concerns the actual code generation. The agent has the information to generate the Python code given the sensor list and the specified rule. In the third step, the agent's thought is to execute the generated code on the actual sensor data. This results in an error due to the unavailability of sensors data. Based on the observation, the agent reacts, and for the fourth step, it chooses from the available tools one that can retrieve and store the sensor's readings. Having overcome the first barrier, the agent resumes the plan by running the code once again. This still results in an error due to the mismatched naming between the code and the data columns. Given such observation, the agent has to fix either the mapping or the code. In step 6, it retrieves the list of available sensors once again. And the agent observes that the condenser water flow column exists in the data, but it is incorrectly used in the code. And in light of the new observation, the code is generated again. And the agent can now rerun the code, all the issues are solved, and the code runs through to completion, raising an anomaly. Like in conclusion, we see that the agent is able to perform high-level tasks autonomously and not only translate the expert rule into functional code, but also grounds it with the actual sensor data names available.
Okay, so another sort of interesting example of how agentic workflows can do automation and actually by generating code, right? And here was a setting where the user provided a rule that they wanted to check, right? It's like a hypothesis testing exercise, right? The agent sort of understood that in order for me to check this natural language specified rule, I need to write some Python code. So it went ahead and wrote some Python code, right? And then in order to sort of really check for this condition, it has to instantiate the code with the right sensor variables, pull the right sensor data, right, and then go test for it. So when it did it in the first iteration, it turned out it came back with an error, right? Because one of the variables was actually not mapped correctly to the sensor variable name. So it's based on sort of self-reflection, it figures that out, right? And debugs that, picks the right sensor variable name, changes the code, and then executes the code, and then tests the sensor data whether that particular condition was being satisfied, right? So it's really interesting to see the kind of automation that we can bring with agentic workflows, right? And just as a conclusion, right? So what is really interesting about this is the ability to use these kind of agentic workflows to essentially start to automate some of the complex tasks that we need to do for CBM, right? And of course, there's big value to be gained, right? There's several studies, including an IDC study that shows return on value to be over 500% over a 5-year period, with for a firm with about 50 maintenance workers, right? This kind of sort of end-to-end workflow really could improve the productivity gain by a few factors on top of it, right? So I think this is the next turn in terms of the embedding and sort of the infusion of Gen AI into condition-based maintenance. Thank you.